Hi, and welcome back to GradStats 2024 in Lab 2. This is the SPSS edition for descriptives and visualizations, which is all about communicating the data to your reader, your audience, your colleague. So we're going to summarize categorical and continuous variables and create graphics to communicate the results. We will also evaluate an assumption of the data called Univariate Normality, and this is typically required for the parametric techniques that we will be using later on in the series. Materials you need are linked in the description, namely the survey dataset called Survey 2024 Lab 2 and an example write-up. So let's get started. Once you open up the dataset in SPSS, you'll see that we have all of our categorical variables. They're all indicated correctly as far as the type of measurement. And we also have at the end of the data the total scores. So those skill level scores for optimism, mastery, positive and negative affect, life satisfaction, perceived stress, self-esteem, social desirability, and perceived control of internal states. So we are ready to describe some variables. To describe categorical variables, we want to know how many and the percentage of the whole sample that group represents. So we'll go to Analyze, Descriptive Statistics, Frequencies. In here, we're going to start with sex variable. So that's one categorical variable that has two levels, male and female. Then we will, instead of hitting OK, I want you to hit Paste. This will open up a new window called the syntax window. And what we have here is that SPSS opened the data set and we asked for frequencies of the variable's sex. So I'm going to select all of that and hit Run with the green arrow. And in our output, we're given how many participants are male, 185, and that's 42.1% of the total 439 people. Whereas we have 254 females, which represents 57.9% of the sample. Next, let's look at this again. So Analyze, Descriptive Statistics, Frequencies, and we'll add in the chart of pie charts. Hit Continue and Paste. Looking at our syntax window, the only difference is this one line asking for the pie chart. So I'll run this. We have the same table that we had before, but now also a pie chart showing the breakdown of male and female respondents in the data set. So we'll try this one more time. Let's go back to Analyze, Descriptive Statistics, then Frequencies. And now let's get all of the categorical variables. So sex and marital, child, education, source, and smoke. And in the charts area, instead of pie chart, ask for a bar chart. So we'll paste and take a look at the syntax. In the syntax, it's still the same command, frequencies variables, but now all of the variables are there and they're only separated by a space. There's no commas or anything. And then the line asking for the bar chart and in order of the analysis. So what order analysis is saying is that the results are going to be in the order that the variables were in the box here, in this same order. That's what it's saying. Okay, running this. Now we have the sex variable. Now we have marital or relationship status, child, education, source, and smoke. Now here you want to notice that some of the variables, child, source, and smoke, have some missing values. And what that means is that some respondents, in the case of major sources of stress, 17 of them did not answer this question. And that makes a difference in the tables we see further down. For example, when we look in the source table, we have percent and valid percent, and the numbers are slightly different. This is because the column under percent takes into account that 17 respondents did not answer the question, and that represents 3.9% of the total 439. But if we only look at the total 422 that answered the question, then out of those who answered the question, the percent of 422. So 53.1% of 422 said that work was their major source of stress. So sometimes knowing the portion that did not answer the question, answer that item in your survey, sometimes that's part of your research, that you are looking at missing responses or responses that did not happen. In our case, for this exercise, we're going to be using the valid percent column. So we report frequency and valid percent. Now, sometimes it's not going to matter. If there were no missing values, then the valid percent and the percent are going to be the same exact numbers. So it only really matters when we have missing. But here's our bar charts. And in the bar chart, we can do some edits, right? If you double click on a chart, you get your chart editor, and you can make some changes in here. This helps when you're when you have an image that you know you're going to want to use in your write-up. Sometimes you want to go ahead and make some changes here to make it more APA. For example, the title of a figure should be in title case. It should be left aligned. So I hit the left align icon there. It's not bold, but it is italics. And if I click within here to where it selects the word, now I can write something else. Also, in the properties, when I select that item right there, I can turn it to Times New Roman because APA doesn't mind us using a different, like not Times New Roman, but it has to be consistent across the whole paper. So that means that I need to figure out a way of making my labels and things in Times New Roman as well, if that's the font style I'm using for the paper. And this looks like it's a little small, so I'm going to bring this up. It's not working there. I have to hit apply. There we go. I always forget that apply button. Okay, that works. Let's see what it looks like. It's cutting off the F a little bit. So what I'm going to do is stretch that box, but that means I also want to move the graph down a little. There we go. And I can also change the font style of the other labels on here. This one, I'm just going to put a space and take it out. And then these, turn to Times New Roman. Okay, so that looks about right for what I might want in the write-up as a figure. So I can close that, and it makes the changes right there on my output. So we're going to run another type of graph, this one building from the chart builder. So I go to Graphs and Chart Builder. In here, I'm going to the class of charts called bar in the gallery, and I want the clustered bar. So I'll drag that into the chart preview area. Over here in the element properties, get display error bars. And then in the variables, I'll take sex and put it on the cluster on X set color. There it goes. We'll take age group 3, so that's down here, and put this on the x-axis, and we'll put total perceived stress on the y-axis. And don't worry if the graph in the preview looks nothing like what you get in your output. It's just doing example ideas. This is ready, and I'm going to hit OK. The reason is it makes too much syntax for us to work through, so I'm not pasting from the chart builder. I'm only using OK when we're working in chart builder. See, that's all the syntax. We don't want to work through that. But here's our chart. And interesting here is that we have some differences between males and females when it comes to total perceived stress. If we look at just the males over time as they get older, it looks like their stress goes down a little bit. But the female's stress seems to stay pretty constant over ages. So when we have our bar chart here, we can also edit it. Double-clicking to get into Chart Editor. Again, we can take this title and move it all the way to the left. We can turn off the bold and turn on italics, which is what we would need for APA, and change the font style to Times New Roman. Because it comes in really small there, I'm going to adjust it. And then because that gets into the chart area, I'm going to move the chart a little bit lower. And then I can also make changes here to make capital P, capital S, and turn it to Times New Roman. There we go. We can also change the label for the legend here. All right, I think we're about done editing this. And that looks like it would be ready to go to the write-up. And how would we get this chart to the write-up? Well, what we can do is export what we've made here. If you right-click on the image, and you go to export, you'll come with your dialog box to export something. And you can export lots of different things. You can export to PDF, which is handy if you have output that you want to look at without having to open SPSS. You can export to Word, but a lot of times it's a mess. But what we're looking for is to export to graphics. And when you have that indicated in the document type area, then look down in the graphics area and we're exporting to PNG. And then we can figure out where we want to save this using the browse button and put it where you know you're keeping your items and give it a name that makes sense to you. Like bar chart Lab2 and then save. And you got to hit that OK at the end. It's like one more click that you got to get. It exports the graph and then you are good there. When we look at these differences, right here, there's only from the highest stress to the lowest stress, it's really only about 3 points different. So even though the chart seems to show a lot of differences, they would still need to be tested to know if the differences are significant. Let's try a different graph with Chart Builder. This one will be a box plot. So I'm resetting, and then in the gallery, I'll go to box plot and I'll choose this first one, the simple box plot, and drag it into the preview area. On the x-axis, put the gender variable, sex. And then on the y-axis, put total perceived stress. Then, in the groups and point ID area, indicate that you want point ID label. What's that going to do is tell us if the ID of each point, especially the ones that are outliers. So this helps us identify outliers in these groups. And then we are ready to hit OK. So that gives us a simple box plot of total perceived stress by sex. On the males group, we have one outlier way out there, ID number 10, and then on the females, we have outliers on both sides. So that's another way we can look at this difference in spread between males and females on the variable of total perceived stress. And again, if you wanted to save this chart, this image, we can export it with a right click and then choosing graphics in the document type and PNG file, and then indicating where you're going to save it and then hitting OK. So let's build another graph. We'll build a line graph using Chart Builder. I'm going to reset the whole Chart Builder area so that I only have the beginning again. And this time in the gallery, I'm going to choose line and then multi-line. And drag that into the gallery. For variables, I'm going to put total perceived stress on the y-axis, age group in 5 groups to the x-axis, and then the set color we'll use the gender sex variable. Okay, let's take a look at this. So between these 5 age groups, I have the stress for females and the stress for males. Okay, so we can use a lot of different types of graphs depending on what you're trying to communicate to your reader or your viewer, whoever you're communicating with. Next, we're going to look at continuous variables. Here we go to Analyze, Descriptive Statistics, and Descriptives. In our table, we are going to pick up age and total perceived stress. In the Options button, we're going to also select kurtosis and skewness. Continue, and then we're going to paste so we can look at this in the syntax window. When you're unsure where your syntax window is, you can use either Command tilde, which is the button right beside the number 1, or on a PC, it's going to be Alt-Tab to get through your windows. You can also select from your windows in the taskbar or the dock to go to whichever window you need to be at. So here's what we just pasted, that we want descriptives of the variables age and total perceived stress. Again, they are only separated by a space. And the statistics we're requesting are the mean, standard deviation, min and max, kurtosis, and skewness. So we'll take this and run it. And we have a little table down here. Tells us how many people answered that question, the min and max, the mean, standard deviation, and the skewness and kurtosis. Positive skewness values are those who are clustered to the left. So a positive skew means that the tail of that distribution is flowing out like to the right, whereas a negative skew would have the tail flowing out to the left, to the lower values. So that tells you that there might be some positive skew going on for these two variables. Kurtosis, a positive kurtosis indicates that the distribution is peaked, like it's kind of very high in the center and it doesn't have very good tails. Whereas a negative kurtosis indicates that the tails are too fat, that you have this like flat distribution with too many values in the extreme in the tails. Next, we're going to build a scatter plot, and we're going to do this by using the chart builder. We'll go up to Graphs and Chart Builder. I'm going to reset this to clear it out, and then in the gallery, choosing Scatter Dot. We're going to take the first option, just a simple scatter plot, and drag it into the preview area. Here we'll put age on the x-axis and total perceived stress on the y-axis. And we'll also get sex, the gender variable, and put it onto set color. Here we'll hit OK. And now we have a scatter plot that is there a relationship between age and total perceived stress. Doesn't look like it. There's no upward trend or downward trend going on here in the data points. And we can see that the males and females are rather mixed in there as well. So returning to our continuous variables descriptives, we're going to run descriptives for all of the total variables. But this time we're going to do it just using syntax. So in my syntax, I have the descriptives for age and total perceived stress, right? But I can copy that with a Control or Command C and then paste it with Control or Command V. And now I want to just add all of my total type variables. And those are, let me move this over so I can see them all. Right here, from total optimism through total perceived control. Notice how it'll also pick up little shortcuts, and I can go ahead and take that by hitting enter. So space, I'm going to hit enter here and then space, and then as I start typing I can see that it gives me the option. So I'll hit enter and then space. There we go. All of the age and all of these, and I'm asking for mean, standard deviation, min, max, kurtosis, and skewness. So I can run that. Depending on what you are doing in SPSS, sometimes it's a lot faster to just write the syntax instead of click through all their menus. And now we have all of these continuous variables, and we can look down our skewness line and our kurtosis line. It looks like our highest skewness is this 890, a positive skew for total negative affect. And then there's a very high negative skew for total life sat, or nope, total self-esteem. That's that one. And then in kurtosis, it looks like total life sat has a really high negative kurtosis, and that means it's really chunky on the tails. So in addition to evaluating skewness and kurtosis, when we're evaluating the normality of a continuous variable, because that's what we're doing here, when we're looking at skewness and kurtosis, we're saying how aligned is this variable to a normal distribution. Non-zero values for skewness and kurtosis indicate that there's a deviation from normal distribution, and that's univariate normality. Univariate just means one variable. We're looking at one variable at a time, and is it normally distributed? We can use another tool in SPSS to look at this in addition to looking at skewness and kurtosis. And this is by using the Explore tool. To get to Explore, we'll go to Analyze, Descriptive Statistics, and Explore. In here, we're going to put total perceived stress in the dependent list. In the label cases by, we want the ID. Make sure you have both indicated in the display area. In statistics area, we're going to ask for the outliers and make sure descriptives is already checked. Continue. Then in the plots area, we're going to turn off stem and leaf, but turn on histogram. We're also going to request normality plots and then hit OK or continue. Here we're going to hit paste and take a look at the syntax. So here's our request of exploring the continuous variable total perceived stress. It's going to label values by ID. We'll get a box plot, a histogram, and a normality plot. And we're going to have descriptives and outliers. And we are ready to roll. So this gave us a lot of information. It gave us the mean and the standard deviation, which we had before. But we also have some of these other things. The 5% trimmed mean, what you want to do is compare that number to your regular mean. And the 5% trim just trims off the edges. Like if there's outliers in there, it would trim them off in the last 5% of the distributions. So 2664 and 2673 are not all that different. So it does not look, according to the 5% trimmed mean, it doesn't look like there's a huge issue with outliers in this variable. We also look at the extreme values table. So the highest values for total perceived stress were 46, 44, right in there. And the lowest values were 12 and 13. If we had like one value that was really far apart, like if we had 40s and then like an 86, that would definitely be an outlier. Our tests of normality, we have the KS, Kolmogorov-Smirnov test and the Shapiro-Wilk. Both of these are somewhat sensitive to large sample sizes, large being over 100 or 200 sample, and we have over 400 sample. So these are typically going to be a little sensitive, but the gist of a normality test is that if you have a significant test, no matter what the estimate was, you're looking at the significance. If the test is significant, meaning under 0.05 on the p-value, then it's saying that normality was violated. So, assumption of normality, a significant test means normality was violated. According to our tests of normality, the variable total perceived stress is not normally distributed because it violates the test of normality. Okay. Another way we look at normal distribution is just visual inspection. We do a visual inspection of the histogram. And yeah, it's kind of peaky as far as the kurtosis. It kind of leans a little bit skewy on the positive side, but honestly, that looks pretty good as far as distribution of a normal curve. Like, you don't want to be super critical, and it's fine. A visual inspection is just your look at it. And as you look at more histograms, you're going to find some that you're like, yeah, I think that's not normal, or yeah, that's good enough. And it's going to be something that you develop over time when you're looking at histograms. Another visual inspection is the normal QQ or PP plot, depending on which program you're using. And the line here is the estimated, what you would expect the data points to land if it was a normal distribution, and where the points are landing is what actually happened. So the further the dots stray from the diagonal line means that you have some violation of normality. And then the box plot. Let's go down to this one. Here we see some extra, these little circles. These are what SPSS is considering outliers. For a box plot, the rectangle is 50% of all your responses, and the dark line in the middle is the median. And then the whiskers go out to the rest of the distribution, but when you have values extending beyond the whiskers, those are considered outliers. Okay, we've done all of our tasks here. We have looked at categorical variables, at continuous variables, and pulled some graphs to evaluate normality. Let's take a look at the write-up. In the write-up, you are communicating to your reader about the sample as a whole, and then getting into describing particular variables depending on what your analysis is about. So this first paragraph is just talking about the participants. The categorical variables indicate how many and the percent of the whole that is represented, whereas continuous variables are shown with mean and standard deviation. Whenever you have a graph, that you are also letting the reader know that you have a graph to help illustrate that item, you let the reader know in text where they're going to find that graph. So on through, all of these are categorical or continuous. Here we're talking about the constructs of interest, or the variables that we might be interested in that data set, which were areas of stress or personal characteristics for this data set. And then in this last paragraph, it's looking at some of those preliminary checks and assumption checking. I put while perceived stress and age were not related. That's the scatter plot. There seem to be differences in stress depending on one's gender. That's our box plot. When you're talking about your evaluation of normality, you let the reader know what type of normality or what type of assumption you were looking at and how you evaluated it. Univariate normality was evaluated for continuous variables, stress and age. Visual inspection of the histogram for perceived stress seemed normal, even though there was a significant Shapiro-Wilks test. So what I'm saying there is I think it was pretty normal when I looked at the histogram. However, there is a significant Shapiro-Wilks test, and that's fine. You're just letting your reader know what you found. When we run the same information on age, you'll see that it is positively skewed, or at least that's what I think looking at the histogram. And it's also significantly non-normal. We can do that in SPSS. The same thing. In fact, we can do it with our syntax. All we have to do is add on age in our syntax and then rerun. And now we'll get the descriptives, the same descriptives for total perceived stress and age. There's total perceived stress. When I scroll down, I also get the histogram for age and the QQ plot and the box plot for age. When you're setting up your figures, you want to, I'm having you put them in the appendix, but you always start with the figure number, the figure title, and then your image. The red areas are where something's wrong APA-wise. Like that should be capitalized, and all of the fonts here should be consistent with whatever font you're using for the paper. Figure 2, I did more editing on this one. I put in count and percentage on the bar graph for highest education completed, and you can do that in your output. But here the red square is because these tags are like pointed downwards, whereas if I go down to the next one, these tags are pointed upwards. And this is all in lowercase, whereas this is all in uppercase. Neither one is wrong, but you want to be consistent. So keep that in mind while you're working with your figures. In here, even though I made changes to the title in the chart editor, I found that it was easier to just not include a title there at all and just put the title here in Word, because I could make sure it was the right location, I could make sure it was the right font, instead of making it part of the image. Figure 4, these need to be APA and correctly capitalized, but there's the scatter plot between total perceived stress and age. And notice that every figure goes on its own page. When you're in the appendix, each table and figure gets its own page. So be sure to take a look through those. So we got a lot done here. We were able to just go right into our data set, didn't have a whole lot of cleaning to do, so that's nice. And then look at describing the categories, the categorical variables and the continuous variables based on the summary statistics that we would use to convey information about the data set holistically. We also were able to pull some different graphs, and you would choose from those graphs which ones you want to include in your write-up, the ones that help convey the information to your reader or your audience. And we also looked at univariate normality, which is an important first assumption check for running parametric techniques, which we would be running at a later date. So good job, and I'll see you in the next lab.